Beams. Beams are horizontal, load-bearing members connected to columns, and they are used to support the weight of floors, ceilings, and roofs of a building, and to transfer the load of a vertical load-bearing element of the structure. This is a beam which is part of a fence. It is likely made out of cedar wood because it lasts 15 to 30 years, are affordable, and in abundance. Wood was chosen because it's durable, long-lasting, and naturally resistant to insects and slow to rot. The cross-section is a rectangle. If it is cedar wood, then it doesn't need any or much corrosion treatment, as the natural oil in the wood will help to deter insect damage and rotting. If it is painted to match with the rest of the house for aesthetics, but also protection against decay. The beam has been screwed into the columns on either side because screws are cheap and easy to use. The nature of the structure means the beam only has to hold its own weight from gravity, but if pressure was applied, it would experience compression. If a lot of force was applied to the top of the beam, it would experience bending, squashing, and rupturing caused by compression. The bottom part of the beam would experience tension, as the wood would want to split into two, and the top part of the beam would experience compression as the load is being applied from the top. Ties. A tie is a flexible or solid member which is used to connect a cantilever to a column. They prevent the column from buckling. It is a tie because it is supporting the cantilever on an electricity pole. It is likely made of steel because steel is durable, reliable, tough, has good tensile strength, won't corrode, and is malleable. The cross-section is a thin rectangle. It has been galvanized to protect the steel from rusting using zinc. It has been screwed onto the wooden post or column and cantilever because they are strong and don't rust, unlike iron nails, and are easily removed if needed. Although most ties experience tension, this tie does not, as it is supporting the cantilever from underneath, making it compression. If forces were increased, the tie would experience squashing and bending as a result of the increased load and compression. Struts. A strut is a diagonal member which is used to brace a square or rectangular structure. Struts are used because they strengthen a square into two stronger triangles. It is an old pet store that is being demolished. It's in Brookvale next to the newly opened Hungry Jack's. It is a strut helping to hold a roof up. Steel was chosen as a supporting member for the roof because it's durable, cost-effective, high strength, light, and shows visible signs before failing. The cross-section, again, is a thin, flat rectangle. The visible signs of rust reveals that there's no protection that has been used. It has been welded on because it is quick, high strength, no stress concentration, and the joint is leak-proof. The member experiences compression from the top to the bottom. If forces were increased, the member would experience squashing and bending as a result of the increased load and compression. Cantilever. A cantilever is a structure where a beam extends from a column and is not supported at the other end. They are used because it's only connected at one side, meaning all other three sides are open for walking through/under or watching, such as a stadium. It is an awning in front of a boutique store in Freshwater Village. It appears to be a COLORBOND roofing, which is made of steel. Steel was chosen for the roof because it's durable, cost-effective, high strength, light, won't corrode, and is malleable. The cross-section is flat to semicircle and repeated. The steel is coated with BlueScope's metallic coating to provide enhanced corrosion resistance, and then a top coat of paint provides resistance to chipping, flaking, and blistering. The cantilever has been bolted onto the main structure because they are quick and easy to install. The connection supports the load as soon as the bolts are tightened. Bolts won't shear or bear. Possibility of failure at the net section is eliminated and safe, as no extreme heat is required. If lots of weight was applied, the entire cantilever would bend downwards towards the ground due to the compression.